This video tutorial provides just a generic overview for procedures for conducting this experiment. Please consult your notes for term-specific instructions. This lab examines pool boiling using several instrumented metal spheres immersed in a pool of liquid nitrogen, which is at negative 195 degrees Celsius. Use extreme caution. We have 5 metal spheres varying in material and size. Each sphere has 2 thermocouples, one located at the surface and the second located at the core. We will be using LabVIEW throughout the experiment to monitor the temperature. Select one of the spheres and use the calipers to measure the diameter at several locations. The liquid nitrogen comes in a large stainless steel tank, which may be rolled around the lab. Anyone working with the tank should wear cryogenic gloves for protection. When you're ready, have your GSI either replenish or fill the glass door at your workstation. Only the GSI may dispense the liquid nitrogen. Once the glass door is filled, close the valve at the tank. The GSI should return the hose to the tank by draping it over the top as shown. Gently connect the extension cables to the thermocouple connectors. Note the C for core and the S for surface. The LabVIEW program used for this experiment is thermocouple log main under the shortcut folder. Once it opens up, let's expand the window and center the panel. Let's zoom in to make sure both thermocouple channels are active, which they are. Also, the fastest we can sample data is at 14 Hertz divided by the number of thermocouples, which is 2. Let's go to the main panel by hitting the Take Data tab. Start LabVIEW and then click on the Take Data button to begin temperature logging. Gently lower the sphere into the liquid nitrogen and be careful not to subject the wires into any unnecessary stress. Using your heat transfer book, try to identify the regimes of boiling described along the pool boiling curve. If the glass door fogs up, turn on the hairdryer, just the air, not the heat. We're going to fast forward a bit, but you're going to notice that eventually the surface temperature is going to take a sudden dip as it goes from one regime to another. Also, eventually you'll see that the core will follow through, do a secondary dip. Continue to run the experiment until both the core and the surface have reached a steady state temperature. Stop LabVIEW and save the data file to the desktop using a clear file name, such as the material type and the actual ID number, such as D2 in this case. Use the handles to remove the sphere from the liquid nitrogen bath and place in the upper nest. Disconnect the extension cables from the thermocouple. Grasp only the connectors, do not pull on the wire itself. Then remove the sphere and place in a bath of water. You'll notice a shell of ice will form around the sphere. Once the sphere has warmed, you can remove it from the water and gently tamp the excess water. Do not twist the sphere, you'll damage the thermocouples. As an alternative to using a paper towel, you can use an air hose to blast the excess water off the sphere. Do so only in the sink though. Before you leave with the lab today, make sure you save your data files to some memory device or cloud server. In conclusion, be safe and follow all safety instructions. Accidents do happen, as shown here with this glass door shattered while filled with liquid nitrogen.